Hi everyone, and welcome to today's lesson of the Bare Basics, which is on your basic log laws. You may recall that log stands for logarithm, which is the tool that we use when we have an unknown in the index of an equation. So let's begin with a reminder of logs. We looked at the example of the exponential equation y equals a to the power of x. This can be written in the alternative form. The log of y to base a is equal to x, and that's how we read it. The log of y to the base a is x. Now, just as we had rules which let us manipulate indices when we had the same base, we can manipulate our logs when we have the same base as well. We begin by looking at a couple of special logs, and the first is this. The log of any number to the same base, so these two must be the same, is 1. And that makes sense because a to the power of 1 is a. Anything to the power of 1 is itself. The second special log is the log of 1. The log of 1 to any base is 0. And once again, that makes sense because any number to the power of 0 is 1. So we're just writing those two index rules as special logs. Now that will be important later on when we come to do some solving log equations. Okay, so let's start off with the logarithm of a product. And I'm going to give you the rule straight out. So our rule is the log of mn to base a is equal to the log of m to the base a plus the log of n to the base a. Now this links straight to index rules. I'm not going to give you the proof at the moment, but we can look at that in another video. Now let's use this as an example, and we'll do the log of 27 to the base 9. Now we can begin by saying that 9 to the power of 1 is 9 and 9 to the power of 2 is 81. So the log of 27 to the base 9 we know has to be somewhere between 1 and 2, but we're not quite sure what it is. Our first step is to express 27 in terms of m times n, and ideally we'll come up with two factors that can actually be expressed to base 9. And so in this case we're going to say 27 is the same as the log of 3 times 9 to the base 9. So using our rule we can say this is the same as the log of 3 to the base 9 plus the log of 9 to the base 9. Now we know that 3 is actually the square root of 9. So 9 to the power of a half is equal to 3. So the log of 3 to base 9 is a half. Then we add that to the log of 9 to base 9. This is one of our special rules, so that becomes 1. Hence, the log of 27 to the base 9 is equal to 1.5 or 1.5. We can similarly do the log of a quotient, which is a division. Once again, I'm going to give you the rule straight up, so write it down. The log of m on n to base a is equal to the log of m to base a minus the log of n to base a. So once again, just as when we have a quotient rule for powers, we actually subtract the indices, we do the same when it comes to logs. So let's have a look at our example of log 27 to the base 9 again. Now this time we're going to express 27 as the result of a division. So we're going to say 27 is the same as 81 divided by 3. So we'll say the log of 81 on 3 to the base 9 is equal to the log of 81 to base 9 minus the log of 3 to base 9. Now we know that 81 is the same as 9 squared, so it's going to be 9 to the power of 2, so the log is 2. And we know once again that 9 to the power of a half is 3 because it's a square root. So we have 2 minus a half is equal to 1.5 or 1.5. So that confirms for us that the log of 27 to the base 9 is 1.5. Our final rule that we're going to look at for today is the logarithm of a power. Now this is a really, really helpful rule, especially when we're dealing with things like finding a log when we're using the simple compound interest, when we're using the compound interest formula. Okay, so the log of m to the power of n to base a is the same as n times log of m to the base a. So what we're doing is we're taking our power and we are moving it to the front of our problem. So once again, we have log 27 to the base 9. So 27 can also be written as log of 3 cubed, because 3 times 3 times 3 is 27. So 3 times 3 times 3 to the base 9. So what we do is we put our index out the front and we say that is equal to 3 times log of 3 to the base 9. Now we've already seen, so that's 3 times, and we know that 9 to the power of a half is 3 because the square root of 9 is 3, and 3 times a half is equal to 1.5 or 1.5. So in 3 different methods, we have just proven that the log of 27 to the base 9 is 1.5. Now let's take a moment to just revisit logs to the base 10. Remember, if the base isn't specified, the log is taken to be to base 10. Now, if we wanted to calculate the log of 1,000 is equal to x, previously we had to rewrite that. We knew it was to base 10, so we'd say 1,000 is equal 10 to the power of x, and therefore we'd calculate x that way. Now we can do it a slightly different way. We know that 1,000 can be written as 10 to the power of 3. So we say log of 10 to the power of 3, and then we rewrite that. So we move our 3 out the front, and that becomes 3 log 10. But we know that this actually means to the base 10, and any number to the same base is 1, because that's our special rule. So our log of 1,000 is 3 times 1, which is equal to 3. And that's how we do logs to the base 10. If you have any questions, just ask in class or email me. The main things to remember are your product rule, your quotient rule, your power rule, and also our 2 special instances, because when you combine them, you can solve all sorts of problems. And how we actually apply them will be dealt with in another video. This has been your Bare Basics lesson on Intro to Log Laws. Remember, the aim of this series of videos is to help make maths more bearable for you.